Assalamualaikum and hi. Today, my group will present the experiment 6 of high performance liquid chromatography HPLC. D is the group member for this group.
Assalamualaikum and hi. I am Dr. Fitri binti Ahmad Fazil, student ID 2022450032, will present to you the introduction and objective of this experiment. Let me start with introduction first. Recent advancements in chromatography technology have expanded the use of high-performance liquid chromatography (HPLC), a technique for efficiently separating small quantity of mixture components. HPLC, similar to liquid chromatography, but with enhanced separation efficiency, use a column pad with fine particle, 5 micrometer in diameter, to create a large adsorption surface as the stationary paste. The densely packed column requires the mobile paste to be pushed through under high pressure. The system includes a detector and computer to monitor elution and guide fraction collection. HPLC identifies samples by comparing retention times. A standard compound is injected to record its retention time and peak area. Then, the sample is analyzed under identical conditions. Matching retention time confirms the analyte identity, and peak area ratio quantify its amount. Reverse-based partition chromatography, the most common HPLC method, use a polar mobile paste and a non-polar stationary paste. This experiment used a C18 column with non-polar alkene bond to silica particle as the stationary paste, while the mobile paste is typically a mixture of water and acetonic acid. Next, I will continue with objective. The main purpose of this experiment is to determine the retention time of a standard solution, caffeine. Besides that, to identify the caffeine peak in a soft drink sample, and lastly, to determine the amount of caffeine in soft drink sample using the response factor.
Hi, I am Nurul Shafira binti Ahmad Nazar with student ID 2022839136. Now, I will explain about the methodology for this experiment, which divided for experimental, block diagram, operating instrument, and sample preparation. For experimental, there are 6 steps. The first step, caffeine stock solution. To prepare stock solution, 10 mg per milliliter, 10 mg caffeine was accurately weighed into a 10 ml volumetric flask. Then it was dissolved with distilled water and it was made up to volume with distilled water. It was labeled as solution A. Then for working solution, 0.1 mg per milliliter, 1 mg of solution A was pipetted into a 10 ml volumetric flask. It was made up to volume with distilled water and labeled it as solution B. Next step, to prepare the sample, 10 ml of soft drink was poured into a small beaker. A magnetic stirrer was used to remove any carbonation. 2 to 5 ml aliquot was filtered through a 0.45 micrometer pure diameter membrane filter to remove particulate matter. Third, 10 microliter of solution B was injected into the HPLC to establish the retention time of caffeine. Then, the peak area of caffeine was measured. Next, 10 microliter of prepared soft drink sample was injected into the HPLC. Lastly, the peak corresponding to caffeine was measured by referring to its retention time. Now, let's move to the block diagram. First, the caffeine standard or soft drink will be going through HPLC solvent reservoir. It is to store mobile phase made up of solvents depending on the type of analysis. Next, HPLC pump. It will suction the mobile phase from the solvent reservoir and go through the column and detector. Depending on several factors including column dimension, the particle size of the stationary phase, the flow rate and composition of the mobile phase, operating pressures of up to 42,000 kilopascal can be generated. Then, the injector is to introduce standard or sample into the Hplc column. Inside the injector, there has sample vial to store standard or sample solution. Next, the Hplc column is usually made of polished stainless steel with length between 50 until 300 ml and have an internal diameter between 2 until 5 mm. They are commonly filled with stationary phase with small particles. After that, for the detector, it is located at the end of the column to detect the electric compounds. The commonly used detectors are fluorescent, UV spectroscopy, and electrochemical. Lastly, for data acquisition, it is the data collected on electronic devices that will be produced from the signal of the detector. And then it will integrate detector response to each compound and change it into chromatograph. For example, data acquisition could be computer, laptop, and printer. Now we move to the operating instruction. To starting the instrument, first, the electrical switch was turned on. Second, the pump switch was turned on. Third, the autosampler was turned on. Next, the switch on the column compartment was turned on. Lastly, the computer switch was turned on. Then, to running the software, first, the Hplc online was clicked. To activate the system, the on button was clicked. Second, the flow of mobile phase was forced for a minimum of 5 minutes. Third, it was set whether to run sample analysis or sequence method. The analysis was wait until complete. Next, the result was saved and was printed. Last but not least, to turning off the instrument, first, when the experiment was finished, the system was flashing at least half an hour. Second, the off button was clicked to deactivate the system. Third, exit and close Hplc online, the computer was closed. Next, the switch on the column compartment, detector, autosampler, and pump was closed. Lastly, the electrical switch was turned off. For sample preparation, a syringe and a filter was used to transfer sample 10 till 20 ml into a vial. The types of filter used is SRP15. Second, to prepare mobile phase, the mobile phase was filtered. For methanol, water, buffer, and acetonitrate, ACN, membrane filter was used. Step 3, use ultrasonic cleaner, which is model UC05. Step number 4, simple injection. Single run acquisition was clicked. The syringe and load were inserted. Sample was injected and turned down. Step 5, control was selected. Then it ran in minute. Step number 6, report was selected. Next it was viewed. Then choose method custom report. Number 7, the results were printed. Number 8, for clean-up process, LC setup assistant was clicked. For mobile phase B, C, and D, it was washed with ACN. 100% ACN was clicked. For buffer, it was washed with water. 100% water was clicked. Lastly, the instrument was switched off.
Assalamualaikum and hi, my name is Nurul Adlina binti Dudley. My student ID is 2022876976. I will present about result and the calculation. In this result, we get retention time and peak area of caffeine for 3 compounds, which is standard caffeine, coke, and Levita. For the calculation, we will find response factor. Response factor equal to peak area caffeine standard over concentration of caffeine standard. So the RF for the caffeine standard is 62.495 ppm. Next, The response factor of caffeine in Coke is 112.027 ppm. And then lastly, the response factor of caffeine in Levita is 178.432 ppm.
Hi, my name is Aina Maisara binti Muhammad Zaini. Today I want to make a discussion for the experiment. The retention time for all three samples are very similar with the value 2.482 minutes for the caffeine standard, 2.481 minutes for the Coke, and the 2.479 minutes for the Levita to travel from the injection port to the detector through the column. This consistency in retention time confirms the presence of caffeine in the both Coke and Levita, as the detector compound match the retention times of the standard. Additionally, the peak area which is proportional to the concentration of caffeine show that Levita has the higher caffeine content with a peak area of 11,115.1 and the concentration 178.4 ppm, followed by the Coke with peak area 7,001.12 and the concentration 112.03 ppm, and the caffeine standard with 6,249.49 peak area and the concentration 100 ppm. This result indicate the Levita contain the higher caffeine concentration among the sample analyzed, which could have slightly more caffeine than standard. Overall, the chromatogram confirmed the identification of caffeine in the test beverage and provide insight into their relative caffeine concentration.
As for the conclusion, this experiment utilized high-performance liquid chromatography to analyze caffeine content. The standard caffeine solution had a retention time of 2.842 minutes and a peak area of 6,249.49. For the soft drink samples, Coca-Cola showed a retention time of 2.481 minutes and a peak area of 7,001.1, while Levita had a retention time of 2.479 minutes and a peak area of 11,151.01. This result demonstrates Hplc's precision in detecting and quantifying caffeine in complex mixture.